Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with the Saibono Discovery Center. Right, so now for today, we will be focusing on your revision for the paper 2 examination, okay? And your paper 2 consists of two sections. It consists of section A, which has 5 multiple choice questions, and that has a total of 10 marks. And we also have your section B, which consists of structured or long questions and has a total of 65 marks. And now the total for paper 2 will therefore be 75 marks, and that is with a duration of 1 hour 30 minutes. Okay. Now, when it comes to the content, we have matter and materials, which consists of 47 marks, and now that will be a percentage weighting of 62. We also have chemical change, which consists of 28 marks, and now that will be a percentage weighting of 38 there for your paper 2, okay? So now these are the topics that we have. Of course, we have multiple choice questions, and as we know, each multiple choice question consists of 2 marks. We have organic molecules, which is your question 2. So that's the start of your paper. Then organic properties, organic reactions, and then plastics and polymers, electronic properties of matter, as well as your electrochemistry. And as we know, the electrochemistry has 2 sections, which is your galvanic cell as well as your electrolytic cell there. Okay. Now, when it comes to organic molecules, you need to be able to define the following organic molecules. Hydrocarbons, as we know, the word hydro, so hydro and carbon, it's just a combination of what? Of a molecule that would be having what? Only hydrogens and what? And carbon. So that is your hydrocarbon. And then functional groups as well. Homologous series, saturated compounds. So as you know, if they speak about saturated compounds, then they would be referring to your what? To your alkanes. And then if they speak about what? Unsaturated compounds, they would be referring to your alkenes as well as your alkynes. And then we also need to know what? We also need to know the definitions of chain isomers, functional isomers, as well as what? As well as positional isomers. Then number 2, write down the what? You need to be able to write down the molecular, the structural formula of organic compounds, and that is up to what? Up to 6 carbons. So now all of this is according to your what? According to your examination guidelines. And then you also need to be able to differentiate between the what? The different homologous series that we have. So I normally call those the family, to say in which family does this compound belong. So make sure that you know all the families or all the homologous series that we have, as well as their what? As well as their structures. And then saturated and unsaturated, we spoke about that. Saturated, we know it's alkanes, and unsaturated is alkenes as well as what? Alkynes. And then also make sure that you know the what? Know the general formula for the different homologous series that we have, and as well as the structures and the functional groups for the different compounds. Because remember, for all the homologous series that we have, if you do not know the structure, if you do not know the name ending or the functional group, then you will not be able to do what? You will not be able to identify it. And then it says know and apply the different what? The different isomers that we have. So you need to now go back and have a look at all the different isomers that we have and be able to apply all of them, okay? Because we don't know which one is going to be asked. And of course, you also need to know your what? Your IUPAC naming. That is going to help you a lot, okay? So now it says the homologous series and the what and the functional group. So this is what we were talking about when we say the homologous series and the families, or I refer to them as families, right? So when we speak of alkanes, then you need to know that if it's an alkane, that is when you have carbon-carbon what single bonds. It says here only carbon and hydrogen and carbon-carbon what single bonds. When we speak of an alkene, then you know that we have what double bonds. And then what is the name of the functional group? It's what carbon-carbon double bond. When we speak of alkynes, triple bond. So therefore the name of the functional group is what? Carbon-carbon triple bond. Haloalkanes, so this would be the structure of the haloalkane. And the X there, because it's a halo, the X there, what does it represent? It represents the halogens that we have. So it could be any of those: fluorine, chlorine, bromine, as well as iodine. Okay. And then next we have what? We have alcohols. For alcohols, the name of the functional group is what? Hydroxyl. So know the structures. When we say aldehyde, then you know it's C double bond O and the H is on the side. What is the name of the functional group? Formal. Ketone, it is when the C double bond O is in between the two carbons, so therefore a carbonyl group. Carboxylic acids, C double bond O, the O and the H there, so therefore a carboxyl group. And then we also have what? We also have an ester, C double bond O and the O, but they must be where? They must be in between the two carbons, okay? So just to emphasize, when they say you must give the homologous series, it means that you are going to give the name, which is this one here on the left. But when they say give the structure of the what? Of the functional group, they are not referring to the IUPAC name. So you need to make sure that you read carefully the structure of the functional group. So this is what they are looking for, just the structure without the hydrogens. But if they say you must give so they can say the structure, this is the structure. If they say give the what? Give the name, then this is what they are looking for, the name of the what? Of the functional group. So say, for example, they say give the name of the functional group of what? Of aldehydes, then definitely it's going to be what? It's going to be a formal group. So please make sure that you read carefully and that you are able to differentiate between the two. Now, when it comes to your IUPAC naming, make sure that you know, because with technical science, we are only going to go up to what? Up to 6 carbons there. So make sure that you know how to write the what? The parent name. To say when it's 1 carbon, it's meth. When it's 2, it's eth. When it's 3, it's prop. When it's 4, it's but. 5, pent, and then 6 will be what? Will be hex. And then when it comes to the IUPAC naming, so in full, it means International Union of Pure and Applied Chemistry. So for the alkanes, okay, you cannot be able to write what? Organic chemistry or the IUPAC naming if you don't know all of this, the name endings, okay? So alkanes, the name ending is what? Is "ane". Alkenes, the name ending is what? Is "in". Alkynes, the name ending is the "ine" there. So if you notice with the first 3, there is definitely what? There is definitely a pattern there. And then the haloalkanes, so the haloalkanes are like your what? They are like your alkanes there. And then with the aldehydes, so we can take this one here. Aldehydes, it ends with a what? With a al. What about the ketones? It's "one" or "on". That's the name ending there. And then with the alcohols, so it's the "all" there and "all" there. Carboxylic acids, it's we are only going to take the word acids, but we are going to add the word what? The oic. So it's going to be oic acid. And then this one will therefore be what? O8. Okay. So know how to write the name ending for all of the homologous series that we have. It's going to help you a lot when it comes to IUPAC naming. And then the tips that need to be noted. Again, we said know all the homologous series, the general formula, and the structure of the functional group. I'd be able to do what? Be able to identify them by structures and be able to write the name of the functional group. So that's exactly what we spoke about there in a summary. Okay. Then next, you must be able to write the general formula. So general formula, it says an expression used to indicate the distribution of atoms in an organic compound in a homologous series. Okay. So we can also explain this as a mathematical formula in a way. So it's like the mathematical formula of of all the homologous series that we have. So make sure that you familiarize yourself with all of them for all the homologous series. Okay. And then also the what? So we'll start with the structural formula. It says show which atoms, the structural formula shows which atoms are attached to which within the molecule. Atoms are represented by their chemical symbols. Lines are used to represent all the bonds that hold the atoms together. So with this one, we are able to see that, okay, carbon is bonded to what? Is bonded to how many hydrogens? So make sure that you know how to write the structural formula. And then from the structural formula, know how to write the molecular formula there. Molecular formula, it says, indicates the type of atoms and the correct number of each. Okay, so the type of atom, for example, we can see that we have carbon. So it's from the very same. How many carbons? 1, 2, 3, 4. So that's all that you are going to do. When they say give the what or write the molecular formula, all that you are going to do is that you are going to write what? You are going to write the number of carbons that you have. So you will write, you'll see there, you count the number of carbons, and then you'll see that you have how many? You have 4 carbons. From there, what is it that you are going to do? From there, you are going to count the number of what? Of the hydrogens. So here it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. And then you can write what? You can write H what? H10. Okay. So that is how you are going to write your molecular formula. Now, if they say write down the condensed structural formula, what are you going to do? It says a condensed structural formula, a formula that shows how atoms are bonded together in the molecule, but it does not show us all the what? It does not show us all the bond lines. So for example, if we look at this one here, you will see that we have C. So you start by writing your what? Your C. And then from there, you count the number of hydrogen on the very same carbon there. So you have 1, you have 2, and then you have what? You have 3 of them there. From there, you move on to the second carbon, which is this one here. Then you will then count the number of what? The number of hydrogens. So you will see that you have 2. So CH2. You move on to the next one. It's C. How many hydrogens? It's 2 of them. And then you move on to this one, the last one. So it's carbon. And how many hydrogens? And 3 hydrogens. So that is how you are going to write your what? That is how you are going to write your condensed structural formula. And if in the examination they give you a condensed structural formula, before you answer, what is it that you need to do? You firstly need to draw your structural formula. In that way, the question is going to be clear whether you even have double bonds somewhere or you don't even have those double bonds, so that you are able to give the correct IUPAC name. Okay, so make sure that you know all these formulas that are listed here. Then let's have a look at this activity. Consider the structural formula of a compound below and identify the type of what? The type of homologous series to which the compound belongs. Remember, we said that we can treat the homologous series as what? As a family. Which family does this compound belong? So what information? This would be a structure of a ketone. So carboxylic in what? Is in between 2 carbons. So definitely that will also not be what? That will also not be our answer. So you answer the question by recalling. From there, you eliminate the answers that you think that are not correct. So in this case, we have then decided to eliminate how many, or to remove how many? 3 of them. So from there, it means that the only correct answer will be what? It will be the aldehyde. Okay. So just to remind you on that one, when you are drawing your structure in. And on the next one, it says the letters A to F in the table below represent 6 organic compounds. Write down the letters that represents the following, okay? So for this one, 2.1.1, it says saturated hydrocarbon. So we say that a saturated hydrocarbon will mean that we have an alkane, okay? So now it means that you must be able to understand that now that, for example, if we look at this one, oic acid, what is the homologous series? It's a carboxylic acid. If we look at this one, yes, it could be a pentane, but if we look at this, what is it that we have? We have a bromo, so therefore it's going to be what? A haloalkane. And then if we look at this one, the carbon that has a double bond O is in between what? Is in between two carbons. So if that's the case, that represents a ketone. And then if we look at this one now, we have a C double bond O and the O, and it's in between two carbons. So therefore this is what? An ester. And then if we look at this one, the name ending is a in, so therefore it's what? It's a alkene. So it means that the only correct answer would be what? It would be this one here. But if you are not sure, then what is it that you are going to do? You can draw the what? Draw the structure, so that you can be able to verify whether it is saturated or unsaturated. But currently, because all of them, we don't have another answer, it means that the only correct answer that we are going to have will be what? It's going to be A. Then, which one represents a ketone? So we spoke about this. We said the ketone is what? It's D. So as we have previously said, that it's very important that you know the what? You know the name ending. So as you can see here, what is it that we used to identify? We used the name ending. Again, what is it that helped us to identify? We use the structures. So if you understand the structures and the name ending, it will be easy for you to answer what your question 2 there in the exam. Then two compounds which are what? Which are functional isomer. Okay? So now what is a functional isomer? It will be compounds that have the same what? Molecular formula, but they are different in terms of their what? In terms of their functional groups. Okay? So now let's have a look. So for this one, 2.1.3, we are going to use what? We are going to use the word cake. Okay? So if we use the word cake, we are saying that this one here is going to represent what? Our carboxylic what? Our carboxylic acid. And then this one, it represents a aldehyde. And then the K, it represents what? Ketone. The E, what does it represent? An ester. So from there, what are we going to combine? We're going to combine the C with the E and the A with the K. So what does that mean? It means that if you have for only functional isomers, not for all of them. Remember, we also have your positional isomers and your chain. So for only functional isomers, when you have a carboxylic acid, then you need to give what? An ester. Or when you have an ester, then you need to give what? A carboxylic acid. Or when you have an aldehyde, then you need to give what? A ketone. Or when you have a ketone, then you need to give what? An aldehyde. Okay, so let's have a look now. Do we maybe have an aldehyde and a ketone? So that's where you start. So yes, definitely, we do have a ketone. D is what? D is a ketone. But if we have a ketone, do we have an aldehyde? For letters A to F, no, we do not have an aldehyde. So therefore D cannot be matched with anything else. Now let's move on and check if we have a carboxylic acid. Let's check now. So do we have a carboxylic acid? Yes, we have a carboxylic acid. Which one is the carboxylic acid? It's this butanoic acid. Okay, butanoic acid. Do we have any other carboxylic acid? No, we don't have any other carboxylic acid. So now we can move on and check, do we have an ester? Yes, we have an ester. Where's the ester? It's on letter E, okay? So from there, we can then draw the structure of the what? We can then draw the structure of the carboxylic acid if we would like to verify there. Okay, so when we draw the structure, it says butanoic acid. So the but tells us what? The but tells us that there's going to be 4 carbons. So we draw the 4 carbons, and then because it's a carboxylic acid, it has the word oic acid there. It therefore means that we are going to have what? It therefore means that we are going to have C double bond O and the OH way at the end there. Okay. So from there, we can now see that, okay, the two structures, we've got 2 structures, one for B and one for what? And one for E. So what is a functional isomer? It will be compounds that have the same what? Molecular what? Formula. But they are different when it comes to what? 2 functional groups. So let's have a look now. If they will be having the same molecular formula, so you can then verify for yourself. So if they don't say, maybe identify or write down the 2 compounds that are functional isomers, they can then tell you to do what? They can then tell you to draw the structure of the what? Of the isomer, for example, for what? For E. So if they tell you to draw the structure of E, because it's an ester, you will know that you are going to draw what? A carboxylic acid. Or if they say draw the functional isomer of B, because B is a carboxylic acid, then you know that you are going to draw the functional isomer. You are going to draw the what? You are going to draw the ester. Okay, so now let's check. So how many carbons do we have on the carboxylic acid? We have 1, 2, 3, 4 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, and 8 hydrogens. And how many oxygens do we have? We have 2 oxygens. And then if we check this one, how many carbons? 1, 2, 3, 4. And then how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. So we write 8. And then how many oxygens? It's 1, 2. So because this is now you double checking yourself if they ask you to draw the functional isomer, okay? So you are going to write your what? You are going to check it by writing the molecular formula. If the molecular formulas are the same, it means that your structure is more likely to be what? To be correct, okay? So for this one, the answer for 2.1.3 is going to be B and what? B and E there. 2.2, write down the IUPAC name of compound what? Of compound D. So with compound D, how many carbons do you have? So you can see that you have 1, 2, 3, 4. So it means that when you start your name, there'll be a but there because you have 4 carbons, okay? So you can then do what? You can then start by saying, okay, if I had an alkane, my name would be called what? A butane. But because this one is a what? So you see now you can then identify it because it's a ketone. So therefore you are going to remove the what? You are going to remove the E. What do ketones end with? Ketones end with the word what? On. So it's going to be butanone, okay? But we can also see that the ketone is on position what? The ketone is on position number 2. So we can write it as butane dash 2 dash what? Dash on, just to indicate the position of the what? Just to indicate the position of the ketone there. Okay. Then it says write down the structural formula of what? Write down the structural formula of compound B. So we had already drew that one. We said because we see a but, it means what? We are going to draw 4 carbons. We are going to have a total of 4 carbons. And then because we see the word oic acid, it means what? We are going to have a C double bond O and what? And an OH. So with this one, it can be on the first position on the left or the first position on the right. So it does not matter. And then from there, you know that your carbon must have a total of what? Must have a total of 4 bonds. So that is what we are going to do there. Okay. On the next one, write down the structure. Okay, the structural formula again of compound what? Of compound A. So compound A, it's CH3CH2. So you to remember this was our what? This was our alkane. So compound A, we have what? The carbon there. The carbon has how many hydrogens? It has 3 hydrogens. So that is what we are going to be doing there. On the next one, it's another carbon. How many hydrogens does it have? It has 2 hydrogens. And then we have what? Another carbon. How many hydrogens? It has 1 hydrogen. What do the brackets mean? The brackets mean that we have a branch. So make sure that you know how to draw that. And then we have another carbon with how many hydrogens there? With 2 hydrogens. And then, so this is a hydrogen. And then we have the last carbon with how many hydrogens? With 3 hydrogens. So that is how, okay, so that is how you'll be able to draw your structure. But the question says, write down the structural formula of the what? Of the chain isomer for compound A. So with the chain isomer, it basically means that you will be changing the chain that you have. So currently with my chain, I have 1, 2, 3, 4, 5. I have a total of 5 carbons. If I'm now drawing, so this is now the original structure. If I'm now changing my structure, I can then have 1, 2, 3, 4 carbons in total. Then I can also have what? So I'll have 1, 2, 3, 4. And then from there, I can then change the position. When I change the position, then this is what I am going to be having. When I change the position, this is what I am going to be having. So what I did is I took this methyl group and I then moved it onto this position here. Okay, so if I do that, and then this would be the structure that I have. So once you are done, remember that you are going to count the what? You can then count the number of carbons that you have for the original structure. You count the number of carbons that you have for the structure that you drew, the number of hydrogens you have for original and for the structure that you drew. And then if they are the same, it means that your structure is more likely to be correct. But if you see that maybe you are missing a hydrogen or a carbon somewhere, then your structure will not be correct. Okay, so the most important thing with this one, when they ask you for isomers, and especially your chain isomers, is that you need to then be able to write the what? Be able to write the name of the IUPAC name. So say, for example, you write the IUPAC name of this one, of the original. The IUPAC name would be what? It would be, since it's 1, 2, 3, so it would be 3 dash methyl, and then what? And then a pentane. So if the IUPAC name is not the same as the IUPAC name of whatever that you formed, again, it would mean that your structure would be most likely to be correct. But if you write the IUPAC name and you see that the IUPAC name that you wrote is then the same as whatever that you wrote, then your structure is more likely to be incorrect. So if we look at this one, it has a total of 1, 2, 3, 4 carbons. That means that the IUPAC name would be what? It would be 2,2 dash dimethyl, and then what? And then butane. So definitely the names are not the same. So therefore this would be what? This would be a correct structure in terms of the chain isomer. Okay, so if you don't understand the question, if they give you a condensed structural formula, you start by drawing the structure, and then you can move on to answer whatever questions that you are asked. Then the next one, write down the general formula of the homologous series to which what? To which F belongs. So they want the general formula again. What is it that we are going to use? We are going to use the name ending, which is the in. General formula would therefore be what? Because you must first identify the what? The homologous series. Where does it belong? it belongs to the alkenes. That's why it has a in. So therefore, the general formula would be H what? CnH what? H2n. And then 2.4.2, they said you must now draw the what? The structural formula for compound C. How do you draw a structural formula? You start by the name ending here, or by the homologous series. The homologous series tells you that it's a pentane. So immediately you see the word pentane, then you know that you need to draw a total of how many? A total of 5 carbons, because pent is what? Pent is 5, and then ane means that you have what? Means that you are going to have what? An alkane. So you start with the 5. From there, you check the whatever that you have as the branches. So it says 2,2 dibromo. You can start with that, or you can start with the ethyl. So 2,2 dibromo. The di, what is a di? Di means that you have what? Di means that you have 2 bromos. Where? On position number 2. That is why it's a 2,2. So also remember, if they ask you to write the what? If they ask you to write the IUPAC name, and you have 2 bromos on the same position, remember to use the word what? Di, to indicate that it's 2 of them. So 2,2 means 2 bromos on the same position, and then ethyl on position number 3. So if now I have the bromine on carbon number 2 here, it definitely means that this is my position 1, this is my position 2, and definitely this would be my position number 3. So ethyl means that I have a total of what? I have a total of 2 carbons there. So my structure would therefore be this way. So from there, what is it that you are going to do? From there, you can then write the rest of the hydrogens that we have here. Sorry, this one is a single line. From there, you can be able to write the rest of the hydrogens. Okay. Then on the next one, we have physical properties. So for physical properties, you need to make sure that you define boiling point, melting point, and vapor pressure. Know the relationship between what? Between your boiling point, melting point, vapor pressure, as well as the what? As well as the intermolecular forces. And then you should also be able to memorize and master the name of the intermolecular forces that we have, and that is for each homologous series, okay? Then this is what we have now. It says physical properties and the what? And the intermolecular forces, okay? So we have what we call van der Waals forces and what? And hydrogen bonds. And under van der Waals forces, we have what? We have London forces as well as dipole-dipole forces. London forces, we know that they are very weak compared to what? To dipole-dipole, and also compared to hydrogen bonds, okay? So London forces, under London forces, what do we have? We normally say that we have what? Triple A. Triple A means what? Alkanes, alkenes, as well as alkynes, okay? And then under dipole-dipole forces, what do we have? We normally say that we have Hake. Okay, so with Hake, what are we saying? The H is our hydrogen, the A is the aldehyde, and then the K is the ketone, the E is the what? Is the esters. Okay, then under hydrogen bonds, what do we have? We have the AC there. A is what? A is the alcohol, C is the carboxylic acid. So if you get into the exam, definitely you know that you are going to get asked a question on this. You can then start by writing what on question 3. You can start by writing your triple A, you write Hake, and then you write AC. So from there, you will know that the triple A, it indicates what, the Hake indicates what, and the AC indicates what. So just to emphasize on this one, when it comes to the alcohol, we need to remember that the alcohol has what? It has one side for what? For hydrogen bonding. And then when it comes to the carboxylic acid, it has what? 2 sides for hydrogen bonding. So if they then ask you about the strength between the two, then definitely you know that the carboxylic acids will be stronger compared to the alcohols. So why? Because the carboxylic acids have what? Have two sides for hydrogen bonding. And then of course we said that in terms of strength, the strength is going to increase from the left to the right. Okay. So please make sure that you memorize this table. It's going to help you a lot when it comes to that question 3 on physical properties. Then also note that as the strength of the intermolecular forces, it says as the strength of the intermolecular forces increases, what happens? The vapor pressure will decrease. So what does that mean? It means that the intermolecular forces and the vapor pressure are inversely proportional. But remember, in chemistry, we don't use the word inversely proportional. So we are going to be using the word what? As the intermolecular force or as the strength of the intermolecular force increases, then the vapor pressure decreases. So that's the language that they would like us to use for chemistry. But to make it easier again, in terms of understanding, as the strength of the intermolecular forces increases, it says here the melting point, boiling point, and viscosity will also increase. So for understanding, I am saying the strength of the intermolecular force is directly proportional to the melting point, boiling point, and viscosity. But remember, for the examination and also for the test and throughout the year in chemistry, we don't write directly and inversely proportional. Okay. So make sure that you say as this one increases, this one will decrease. That's the language that you need to use there. And then again, we're still on physical properties. So this one, what is it that you are going to use it for? To answer that 4 marks question. Do you remember that 4 marks question that always comes out in the examination? So for the 4 marks question, you are going to use the word what? Ice. Ice means what? You are given that type of intermolecular force. So that's your I there. Intermolecular force. So you are given the type of intermolecular force, which is also what? An independent what? Variable. And then for C, then you are going to compare the strength of the intermolecular forces that you have. So you are comparing to say, okay, a carboxylic acid is stronger than what? Carboxylic acid is stronger than alcohols. Why? Because carboxylic acids have 2 sides for hydrogen bonding, while alcohols have one side for hydrogen bonding, or hydrogen bonding is stronger than what? Then dipole, or is stronger than London forces. So that is now you comparing. From there, you give the what? You give the energy to say more energy is required to overcome the intermolecular forces, or less energy is required to overcome the intermolecular forces. Because remember, we said that we are not going to be breaking the bonds, but we say that more energy is required to overcome the intermolecular forces, not to break the bonds. Okay. Then these are the variables that we have. So for independent variables, you can use this for yourself to remember. Independent variable is the one that would be changing. And for us to remember, we can use IF chain mob, whereby the I is the intermolecular forces, the F is the functional group, the chain is the chain length, MO is the molecular mass, and the B is the branch. Okay. So when we have this, then what does it mean? I am saying that if they ask you to give an independent variable, you are going to read your question. From reading your question, then you can then identify and see if you have any of the following. If you have any of the following, that is what you are going to state as your independent variable. Dependent variable is the one that you would be measuring. So in this case, we don't have a lot. We just have the melting point, the vapor pressure, as well as the boiling point. So make sure that you know the independent variable as well as the dependent variables that we have there. Next, this one says, study the table below and answer the following questions. Okay. So with this table here, we have methane, ethane, propane, as well as butane. And then we are also given the boiling points. So you will then notice that the highest boiling point is which one? The highest boiling point is negative 0.5. So make sure that you understand the numbers. Just because this one is bigger, it does not mean it's the highest. So according to the number line, this would be the highest boiling point. So it says which one of the above molecules has the what? Has the lowest vapor pressure. What's the relationship between vapor pressure and what? Vapor pressure and the boiling point. So you see now, if you understand the relationship, you will be able to answer this multiple choice question. So what's the relationship between boiling point and vapor pressure? We said that as one increases, the other one decreases. So what does this mean? It says which one of the above molecules has the what? Has the lowest vapor pressure. So it means that the one that will have the lowest vapor pressure, going back to the table, will be the one that has the highest what? Boiling point. And then we said that if you look at this table here, the one that has the highest boiling point would therefore be what? Would therefore be the butane. So it definitely means that it cannot be A, it cannot be B, it cannot be C. So definitely it means that the correct answer can only be what? Can only be D. Why? Because we are saying that the relationship between vapor pressure and boiling point is that as the lower the vapor pressure, because they said which one has the lowest vapor pressure, the lower the vapor pressure, the higher the boiling point. So the one that has the highest boiling point is what? Is the butane. So hence that's why it's the correct answer. Okay. On the next one, it says the relationship between the chain length. The relationship between the chain length and the boiling point is investigated. Okay. So when you read again, sometimes there is answers in the statements. So the relationship between the chain length and the boiling point is investigated. So chain length, what are they talking about? Here you can see that you have ethene, so it has 2 carbons. Here it's but, so it's 4, and then here it's what? It's 5, because it's a pent. Okay. So it says using 3 different organic compounds which belong to the same homologous series. Can you see that as well? It says using 3 different compounds, all of them belong to the same homologous series, and the results is given in the table below. So we are given 3 compounds, A, B, C. We are given the names of those compounds. We are also given the what? We are also given the boiling points. Okay. 3.1, define the term boiling point. So again, we're going to define according to the examination guideline. So it says the temperature at which the vapor pressure of a liquid equals the atmospheric pressure. So we are not going to give that grade 11 definition or grade 10 definition. We need to give this grade 12 definition according to the examination guideline. Okay. Then 3.2, write down the name of the homologous series to which compound A, B, and C belong. So remember, we said if you know the name ending, it's going to do what? It's going to help you. Okay. So the name of the homologous series, remember I referred to the homologous series as the families. To say in which family does it belong. So it's going to be what? Alkyne. Okay, alkyne, you can even see the name ending there. Okay. For this investigation, write down the what? Write down the independent variable. So now just to remind you here, we said the independent variable is the one that changes. So again, we can then use this, right? IF chain mob. But remember, if we read the statement, they said that the relationship between what? The chain length and the what? And the boiling point. So if we look at this IF chain mob, you will see that the chain is there. And we also spoke about this to say here we have 2 carbons, 4 carbons, and what? And 5 carbons. So which one is changing? Which one is the independent variable? It therefore means that it's going to be the what? The chain length. Okay. Then the controlled variable. So which one there stays the same? What is controlled? What remains the same? What does not change? So we said, so obviously we said that the IF chain mob represents the what? It represents the independent variable, and then we know that the dependent variables can only be melting point, boiling point, as well as the vapor pressure. So what stays the same? If you look at the statement, they said 3 different organic compounds which belong to the same homologous series. So therefore the same, because the homologous series does not change, therefore that will become our what? That will become our controlled variable. So the homologous series in this case, right? Then explain the difference in boiling point of compound A to compound C by referring to the chain length, the intermolecular forces, as well as the energy involved. Okay, so we had 3 compounds, A to what? A to C, and then at the bottom we had the ethene. At the top we had a pent, which had a total of what? Which had a total of 5 carbons. So now they would like you to explain the difference in the what? The difference in the boiling point there. So what is it that we are going to do? It says only London forces are present. Why London forces? If you remember we said we have what? We have the triple A. Triple A is what? Alkane, alkene, and what? An alkyne. So because all of them had the name ending "ine," it therefore means that they are what? They are alkynes. So if they are alkynes, they are going to be under the category of what? Of London forces. So it says only London forces are present in compound A. So it should be compound A to 2, or we can say and or 2, compound what? To compound C. So all of them have London forces because all of them had the name ending what? "ine." Okay, and then compound A has a longer chain length compared to what? Compared to compound C. Do you remember that compound C only had what? Only had 2 carbons, and then compound A had a total of what? Of 5, because it was a pent. Then it says the longer the chain length, the stronger the intermolecular forces, and then from there you can then conclude to say, therefore it means more energy is needed to overcome. So I would rather say overcome the intermolecular forces in a compound, in compound what? In compound A, as in compound A, then in compound what? Then in compound C then. Okay, so it means that for this one, so this is a 3 marks or a 4 marks question. It means that you can still use the word ice. Okay, with the word ice, what is it that you are doing? Firstly, you are writing the type of intermolecular forces that you have. So we said that we have what? We have London forces. Okay, so that is you now stating that what kind of intermolecular forces do I have? Then we are saying that we have London forces for letters what? For letters A to letter C. From there, what is it that we are doing? From there, we are going to compare to say which one is now stronger between letter A to letter C, because we know that we only have London forces. So when comparing compound A, because compound A has a longer chain length than compound C, therefore we know that the longer the chain, the stronger the intermolecular forces. So that is us now comparing. From there, you can then conclude by talking about what? By talking about the energy, because it says, therefore, more energy is needed or required to overcome the what? The intermolecular forces that we have in A as compared to the intermolecular forces that we have in C there. Okay. Now on to the next one. Which compound will have the highest vapor pressure, and give a reason for your answer. So it was compound A, B, and C. So which one will have the highest vapor pressure? What's the relationship between vapor pressure and the boiling point? The higher the vapor pressure, the higher the vapor pressure, then it's going to be the lower the what? The lower the boiling point. So it therefore means that now which one has the lowest boiling point? It's going to be compound what? Compound C. So again, what's the reason? It says the lower the boiling point or the intermolecular forces, then the higher the vapor pressure. Or the way that I said it initially, you can start by writing about what you have as your vapor pressure, which is the higher the vapor pressure, then the lower the what? The lower the boiling point there as well. Okay. Then on the next one, consider the graph below that indicates the boiling points of alkanes and what? And aldehydes. Identify the homologous series represented by graphs A and B respectively. So when it comes to the identification now, we can then look at the boiling points to say which one has the highest boiling points. So we can obviously see that B will have a higher boiling point compared to this one, compared to B. Okay, so one is what? One is an alkane and one is an aldehyde. So how do we know which one is which one? We know that definitely alkanes, they belong to what? They belong to London forces, and then aldehydes, they belong to dipole forces. How do we know? Remember, when you get to the exam, you write your triple A, your Hague, and your AC. So aldehydes will be there, and then alkanes will be there. Okay, so if this is the case, then it therefore means that the one that has a higher boiling point will be the stronger one in terms of the intermolecular forces. So therefore, it means that the A would be representing the what? The aldehydes, and then the B will be representing the alkanes there. Okay, why? Because I'm saying it's because aldehydes, they belong to what? To dipole forces, which are stronger than what? Which are stronger than London forces for what? For the alkanes there. Okay, and on the next one, it says there, explain the difference in the boiling points of the two homologous series represented by graph A and B, and refer to the type and the strength of the intermolecular forces. Again, what is it that you can use? You can use the word what? You can use the word ice to explain. So I, that is you now talking about the type of intermolecular forces that you have. So for alkanes, you know that the type of intermolecular forces that you have is what? Is London forces. Aldehydes, dipole forces. So that is you now talking about what? The word I. From there you are comparing. Which one is stronger? You know that dipole forces are stronger than London forces. From there you can talk about the energy. Therefore, more energy is required to overcome the intermolecular forces for aldehydes as compared to alkanes. Okay, let's have a look now. So it says aldehydes have what? Have dipole forces, and alkanes have London forces. So that is you now talking about what type of intermolecular forces do you have. So can you see this question? That's the 3 marks question that we were talking about. Then you are comparing. C is compare. You are comparing. Dipole forces are stronger than what? Dipole forces are stronger than London forces. Then E, you are talking about what? The energy. Therefore, more energy is required to overcome the intermolecular forces that you have in aldehydes compared to the intermolecular forces that you have in alkanes. Okay, so learners, I hope that you got that one there. Okay, next one is organic reactions. So for organic reactions, you must be able to identify the following reactions: combustion or oxidation. So just remember, if they say combustion or given a combustion or given an oxidation reaction, just remember that it's exactly the same thing. So do not get confused and say that I do not know what combustion is, or I do not know what oxidation is, or confuse the two. It's exactly the same thing. Then from there, substitution, addition, as well as esterification reaction. So remember, for esterification reaction, you are going to use what? You are going to use ACE what? ACE water. ace water, it means what? It means that you will have a combination of an alcohol with a carboxylic acid. It will give us what? It will give us ester plus by water. So if you are asked to write the structure of what? The structure of an ester, you know that it will be made up of what? Of an alcohol plus by a carboxylic acid. And the combination of the two, what is it that they are going to give you? They are going to give you E, which is an ester, and what? And the water. Hence, that's why we say ace water. So be able to interpret the flow diagrams, and then, of course, very important, make sure that you know all the reaction conditions that we have for the different reactions. So you should also know the types of what? The types of reactions that we have, as well as all the reaction conditions that we have. Then we have addition and substitutions. So these are the acronyms that you should remember. When we say USA, what is it? It means that if you are given an unsaturated reactant, so on the left, this is a reactant. If you are given an unsaturated reactant, you are forming a saturated product. So P is product, R is reactant. Then the type of reaction would be what? The type of reaction would be addition. But if you have a saturated reactant, you are forming a saturated to saturated. You are forming a saturated product, then the type of reaction that you would have would be what? Would be substitution. Okay? So please make sure that you memorize all of this, as you only have two of them to memorize. So USA, unsaturated to saturated, addition. Triple S, saturated to saturated, therefore it's going to be what? Substitution. Okay. And then we also have a Markovnikov's rule. It says to determine which product is formed, we use what? We use Markovnikov rule, which states that in an addition reaction, the hydrogen attaches to the carbon with the greater number of hydrogen atoms, and then a major product will be formed. So how does Markovnikov work? So just to remind you, so if, for example, you have the following, and then you have a double bond there, and then you need to add what? You need to add, for example, you need to add HBr, okay? Now, this is what Markovnikov is saying. This is what Markovnikov is saying. Markovnikov is saying that the carbon that is already rich with hydrogens will become even more richer with hydrogen. So we normally say that the rich gets richer. Okay, so let's read again. It says, which states that in an addition reaction, the hydrogen attaches to the carbon with the greater number of hydrogen atoms. Okay, the hydrogen attaches to the carbon with the greater number of hydrogen atoms, and therefore you are going to form a major product. So this statement is very, very, very important. Let's have a look. If I am trying to add HBr on this one here, where am I going to add the hydrogen and where am I going to add the bromine? So Markovnikov said the rich will get richer. What does that mean? The hydrogen will attach to the carbon that has a lot of hydrogens. So let's see which one. It means that we can only attach it, let's say, by carbon number 1 or carbon number 2. So let's have a look. Between carbon number 1 and carbon number 2, which carbon is already richer when it comes to hydrogens? It's going to be carbon number 1, which is this one here. So Markovnikov is saying that the hydrogen will be attached to the carbon that is already rich, because this one has 2 and this one has what? This one has 1. So this one has 1, this one has 2, so it's going to get 1 more. And then if we have now used the hydrogen, we no longer have the hydrogen, we are going to use the what? We are going to use the bromine there for position number what? For position number 2. Okay, so please make sure that you understand Markovnikov and that you are also able to apply it correctly as well. Then the combustion of propane, it says propane is the gas used in Bunsen burners in the laboratory, and then it says propane burns as follows. So this one is combustion or oxidation reaction. So for this one, what's important, when they say write the oxidation or the combustion reaction, what they are looking for, number one, if they give you a structural formula, so let's say you had 1, 2, 3, so that's what we have there. You have 3 carbons as a structure, and how many what? And 8 hydrogens. So that's the structure of what we have there. So number one, you write that structure in terms of the molecular formula. Number two, what is it that you are going to do? You add your oxygen. Number three, you are always going to form two products when it comes to oxidation or combustion, and those two products will be what? Will be CO2 as well as H2O, and then from there you are also going to have your what? Your energy. But when it comes to the combination of these two, please make sure that you write CO2 and what? And H2O. And then from there, what is it that you're going to do? From there, you can then balance the reaction, because normally they'll say write the balanced reaction in terms of combustion or in terms of oxidation. So I hope the instructions are clear. Number one, write the molecular formula. Number two, you are adding oxygen. Number three, you are going to form CO2 and H2O. And then you're also going to form energy as part of your products. And then number four, make sure that you balance your reaction. Okay? Let's have a look at the following. When petrol, which is a mixture of alkanes, is used in car engines, reacts with oxygen, the reaction is known as A or N reaction. Okay, so because they're saying that it reacts with what? It reacts with oxygen, there is only one reaction that we know where there is addition of what? Where there is addition of oxygen. So it cannot be addition, it cannot be your substitution, it cannot be your hydrohalogenation. So therefore, it means that it can only be your what? Your oxidation. So if you then understand an oxidation or a combustion reaction, it will be easy for you to answer this question here. On the next one, it says prop 1in can be converted to other compounds by means of different organic reactions represented by A, B, C, and D as shown in the following in the flow diagram below. Okay. Write down the type of reaction that would be represented by what? That would be represented by B. Okay. So what is it that you are going to do? You see that you have what? You have prop 1in and the alkane. So you can write your USA and your triple S. With that, what are you saying? We are trying to check if you have an unsaturated reactant or a saturated reactant, or what is it that you have. So because it's a prop 1in, then definitely it is what? It is unsaturated. But if you are still not sure, what is it that you can do? You can draw the structure prop 1in, because it's a prop, it's going to have 3 carbons, and then 1in, it means that we have a double bond on position number 1. So it is unsaturated, as we can see. And then if it's an alkane, it means what happened? It means that they took the very same structure, and then what did they do? They added 2 hydrogens. Okay, so they took the very same structure, they added 2 hydrogens. So if you are moving from an alkene to an alkane, it means that you have an unsaturated reactant. It's unsaturated because it has a double bond. 2S saturated because there's no double bond now, and therefore the type of reaction would be what? It would be an addition reaction. Now, so 4.1.1 would be addition, and then 4.1.2, it says write down the type of reaction represented by what? Represented by C. So with C, you are moving from this one. Where are you moving to? You are moving to a haloalkane. With the haloalkane, what happened? Something happened there with the chlorine. But what is it that you can see? You can see that already you are moving from an alkane. An alkane is what? An alkane is saturated. So you are moving from an alkane to you are moving from a saturated what? Reactant. The haloalkane will also be what? Will also be saturated. So therefore, what is the type of reaction that you are going to have? It is going to be substitution. Again, if you are still not sure what is it that you can do, you can then draw your haloalkane, because you know that you are only going to have a substitution of what? Of one chlorine. Okay, so upon drawing your haloalkane, you will see that the reactant, this one, it's saturated. The product is also what? Is also saturated. Therefore, the type of reaction is what? The type of reaction is a substitution reaction. Okay. Next one, write down the name or the formula of the inorganic reactant that is used in what? That is used in B. So they are looking for, remember we drew the structure of the prop one in. So how did we draw the structure? We said prop. Prop means we have, so prop means that we have 3 carbons, and then the in means that there's a double bond on position number 1. And then we also drew the structure of the what? Of the, we also drew the structure of the alkane there. So with the alkane, we said that it means that we must have had an addition of what? Of the hydrogens, because this one was empty initially. So therefore, there was addition of hydrogens. So if this is the case, then it says name or the formula. So please make sure that you read carefully. If they say the name, then you write the name. But if they say the formula, then you give the formula. So in this case, the name would be what? What is it that was added to make this an alkane? It was hydrogen. So from there, it means that you are going to write what? If they say the name, you write hydrogen. If they say the formula, you can write H2. So it's H2. Why? Because hydrogen is a diatomic element. So also remember that. So yes. So because now they said write the name or the formula, it means that you can write what? Any of the two. And then 4.2.2, the IUPAC name of the haloalkane that would be formed where? That would be formed in reaction what? That would be formed in reaction C. So we said that we are moving from an alkane to a haloalkane. So for you now to be able to see, what you have in terms of that haloalkane, we said that you are going to have to draw the what? You are going to have to draw the structure. So what is the structure that is going to be formed when we replace the hydrogen there? So we're replacing one hydrogen with what? With one chlorine. So therefore, the name would be what? It would be 2 dash. So it's not visible there. So it would be 2 dash what? Chloro. Why 2 dash chloro? Because the chlorine is on position number what? Position number 2. And therefore, because we have a total of 3 carbons, 1, 2, 3. So 2 dash chloro what? Propane. Okay. And on the next one, it says the formula of the catalyst that is needed in reaction what? In reaction B. So please make sure that you know all the catalysts that we have. So it's PT, PD, and Ni, or also they can say, write down the names. So it would be platinum, palladium, and nickel there. During reaction D, the haloalkane reacts in the presence of what? Of a strong base to form an alcohol. And then they're saying, for reaction D, write down the type of substitution reaction that is represented by what? That is represented by D. Okay. So remember, we had drawn the structure of the haloalkane. Now they are saying that you must now write down the type of substitution reaction. So the type of substitution reaction, if they add a strong base such as what? Such as sodium hydroxide, what is it that we are going to form? It's going to be what? Hydrolysis. So also make sure that you know all the types of reactions that we have in terms of substitution, all the types of reactions that we have in terms of addition, as well as the catalyst or the reaction conditions that are needed there. Now, a fully balanced chemical equation using structural formula for what? For the very same compound D. So if we are moving from this one to this one, how do we then move there? Okay, so remember this one, we then showed you how to move from the alkane to the what? To the haloalkane. So now the very same haloalkane, which is this one, when it reacts with what? When it reacts with the sodium hydroxide, what is it that you are going to form? So what happened there? This sodium is the same as us having Na and what? And the OH there. So the OH is the one that's going to be responsible for forming the what? The alcohol. And then the sodium, the Na, is the one that will be responsible for forming the sodium chloride. So what is it that we did then? The OH removed the chlorine, this one here. When it removed the chlorine, it then bonded to the carbon on position number 2. From there, what is it that we were left with? We were left with the sodium. Hence, that's why we have Na as well as what? As well as the Cl that was removed. So that is how we are going to draw the structures that we have there. So also make sure that you familiarize yourself with these types of questions, guys. Then it says rewrite the incomplete chemical equation for the complete combustion of what? Of butane shown below in your answer book. Complete and balance the equation using what? Using molecular formula. They even write the molecular formula for you in what? In capital letters, so that you are not able to what? So that you don't miss it there. So they have given you this one, which is your butane, and they are adding what? They are adding oxygen. So because they said what? Combustion, then you know that definitely you are always going to form what? You are always going to form your two products there. Okay, so after forming your two products, what would be the next step? The next step would then be for you to balance whatever that you have there. So with balancing, then you can write CHO, CHO. So just to write whatever that you have in terms of the elements. So carbons, we have 4, hydrogens, we have 10, and then oxygens, it's 2. Carbons on the right, it's 1, hydrogen is 2, and the oxygen, it would be 2 plus by 1. It's a total of what? It's a total of 3. So from there, you can then balance according to what you have. So if we start with the carbon, we can put what? A 4 there for the carbon. That would mean that we would have a total of what? Of 4 carbons there. And then if we can then move on to the hydrogens, you will see that on the left we have 10, and then on the right we have what? We have 2. So therefore, if we put a 5, how many hydrogens would we have? We would be having 10. And then from there we can try and balance the number of what? The number of oxygens. So we can see that we have what here? So it's 4 times 2, which is what? It's 8, plus by 5 multiplied by 1 is what? Is so it's 8 plus 5, which would give us a total of what? Which would give us a total of 13. But on the left hand side we have what? On the left hand side we have 2 there. Okay, so from there we can then check to see if there's nothing more that we can do. So because we have a 2 and a 13, we can then try and put what? We can then try and put the 13 there. So when we put the 13, you will then see that we have a total of what? we have a total of 26 oxygens where on the left hand side. Okay, so from there you go again. So when it comes to balancing, it will be a trial and error. You will then go again, add more numbers, or you double the numbers up until you get what the same number on the left as well as the same number that you have on the right hand side. So you will then see that if we then double the numbers that we have, so on the carbon here we had we didn't have, or we had 1, so therefore we now have 2. And then on this one we had what? We had 4. If we double, we now have a 8. On this one, if we double, we now have what? We now have 10. So from there you can then go back again and check if it is now all balanced. If you look on the left hand side, it's 2 times 4, so we have 8 carbons, and then we also have 8 carbons on the right. Hydrogens, we have for the hydrogens we have 2 times what? 2 times 10 again, and 2 times 10, so it means that it would be balanced. And then we said on the left we have what? We have a total of 26 oxygens, so therefore if we then have the 8 times 2 plus by the 10, it would also give us a total of what? Of 26. So also make sure that you know how to balance them. Okay, moving on to the next one, polymerization. It says a chemical reaction in which monomer molecules join to form what? Join to form a polymer. So identify monomers from given addition polymers. So you must know how to write the structure of a monomer. And then from there, you should also know how to write a structure of what? Of the polymer. Okay. It says the structure of the polymer can be represented by CH what? CH2, CH what? CH2, which is the same as this one here. So it's CH2 and what? And CH2. The N just indicates that we will have a lot of CH2, but in a repeating pattern. So when it's a monomer, it is called an ethene. But when we have a repeating unit, when we have a lot of them now, but without the double bonds, when we have many, so poly means we have many of the what? Many of the ethenes. So also just make sure that you understand that one well. And then when it comes to plastics and polymers, you should be able to define macromolecule, polymer, monomer polymerization, as well as plastics. Be able to identify monomers from given addition polymers, and also be able to give the industrial uses of what? Of polyethylene. Okay. Then it says the following represents part of a polymer. So polymer, we said it means we have many. Monomer, it's when we have one. Define the term what? Polymer. So we just spoke about this one. It says a large molecule. So the key word would be a large molecule composed of what? Composed of smaller monomers. Okay. So make sure again that you define according to the examination guideline, and then it says give the name of the polymer. So sorry, it continues to say of units bonded to each other in a repeating pattern. Okay, and then so give the name of the given polymer. So because there are many, it would be poly to indicate that there are many. So it's going to be many of the ethenes that we have there. Okay, next we have electronic properties of matter. So you need to be able to define what? Semiconductors, intrinsic semiconductors, as well as doping. Be able to identify the semiconductors and the intrinsic semiconductors. Know the elements that can be used for doping, and also group number 3 as well as group number 5. Be able to discuss the N-type and the P-type semiconductor, as well as the construction and the working of a PN junction. Know the characteristics of the PN junction. Okay. Okay, learners. I will ask that we take a 1 minute break, learners. Okay, welcome back, learners. So let's have a look at the following. It says semiconductor devices such as diodes are widely used in modern electronics. And then number one, they want you to define the term what? Doping. So it says the process of adding what? The process of adding impurities to intrinsic what? To intrinsic semiconductors, okay? The process of you adding impurities to intrinsic what? Semiconductors. 5.2, it says, besides silicon, provide an example of what? Of intrinsic semiconductors. So even if you go back to the periodic table, you will see that silicon is where? Is on group number 4. So it means that, in other words, they are already giving you a clue as to where you can find your answer. So it means that group number 4, that is what we have as intrinsic what? Semiconductors. Okay. So it says, besides silicon, provide other examples that we have. So other examples would be your what? Your diamond, or Ge, which is your germanium, or Sn there, which is your tin. So other examples would be from group number what? Would be from group number 4 there, because group number 4, that is what we have as our intrinsic semiconductors. Okay. Then it says the conductivity of silicon is improved. So the conductivity of which one? The conductivity of silicon. It says it is improved by adding of small amounts of what? Small amounts of gallium, which is this one here in group number what? In group number 3. So for this chapter, you just need to make sure that you know the names of these elements that we have in terms of group number 3, the elements that we have in terms of group number 4, and the elements that we have in terms of group number 5. Because definitely, if they don't ask you about group 3, they will ask you about 5, or they will ask you about a combination of 4 and 3, or 4 and 5. So make sure that you know when they give you a symbol, you can refer back to the periodic table. When they give you a symbol again, you can be able to give them the name of the element, okay? Otherwise, it's going to be a struggle to answer the questions if you don't know the names or the symbols, okay? Then it says, what type of semiconductor material is formed during this process? So if you combine group number 4 with group number 3, what type of a semiconductor are you going to be having? So definitely it's going to be what? A P-type, because remember we have a P-type as well as a N-type. Then it says that you must give a reason for your answer. So what is it that we know about P-types? It says doping silicon with group 3, such as gallium, will form positive charge carriers, or what? Or holes. So group 3, it forms positive charge carriers, or it's going to have holes. Why? Because it has what? 3 valence electrons. And then group 5 has an excess because it will have 5 valence electrons. Okay. Then it says, consider the PN junction diode connected to a power source represented in the diagram below. Is the diode above a forward bias or a reverse bias? And then the next one says that you must give a reason for your answer. Okay, so let's have a look now. This one, so just remember the positive line, the positive one would be represented by the longer line, and the negative one from the cell would be represented by the shorter line. So you need to be able to identify. Once you have then identified, it will then help you to then say that, okay, if I have my P-type and it's connected to the positive terminal of the cell, it means that I have a forward bias or a reverse bias. So what kind? In this case, it means that we have what? We have a forward bias. Why do we then have a forward bias? Because the next question says that we need to give a reason for the answer. Let's have a look now. The P-type material is connected to the positive terminal of the cell in this case, and the N-type material is connected to the negative terminal of the cell. So hence that's why it's a forward bias. It says here it's because the positive terminal of the cell or of the battery is connected to the what? Is connected to the p-type material. And you can also say that because the negative terminal of the cell is connected to the n-type material. So it's p-type connected to the positive terminal. So it's p and p, and the n-type connected to the negative terminal. So it's n and n. But if it was a reverse bias, then what would we say? We would say it's because the positive terminal of the cell would be connected to the, so it would be the positive terminal of the cell would be connected to the n-type material, and the negative terminal of the cell would be connected to the what? Would be connected to the p-type material. So just make sure that you know how to differentiate between a forward bias as well as a reverse bias, and also be able to write the reason or the whole description of why you are saying that you have a forward bias, or why you are saying that you also have what? A reverse bias. Then it says study the representation of the p-n junction diode labeled AB in the diagram. So we have SiP, silicon, phosphorus, aluminium. Okay, are the symbols for what? For silicon, phosphorus, as well as aluminium, respectively. So remember this one, we said that you are going to need to use the periodic table actively. So, okay. So this one then says, what is meant by an intrinsic semiconductor? So the definition for an intrinsic semiconductor is what? Is a pure semiconductor. And we said, where do we find them? We find them on group number what? Group number 4. Which side, A or B, is the p-type semiconductor material? So you can either use the picture, or you can use this one here of the diode. So this one, the triangle, we said it's going to be P for what? For pointing. So the pointing side, the triangle side, is the p-type because the triangle is pointing. So remember, previously we said that because it's pointing, it would be the p-type, and then this side, because it is not pointing, it would be the n-type, okay? Otherwise, you can also look at the combination of the two to say, okay, if I have what? If I have silicon, and silicon is combining with aluminium, I know that aluminium is a what? Or group 3 is what? It's p-type. And then if I have silicon, so I was speaking about this one, silicon combining with aluminium, group 3. Or if I have silicon, which is group 4, and silicon is combining with what? Phosphorus, which is group 5, I know that group 5 is what? Is n-type. So if you're not able to use the diode, then you can then still analyze and use the what? And use the two pictures that you are given. So which side, A or B, is the p-type? That means that it would therefore be what? It would therefore be A, that's the p-type there. And then B would definitely be the n-type. Okay. Then we have electrochemistry. So with electrochemistry, make sure that you know how to define all of this. Oxidation, reduction, your oxidizing agent, reducing agent, electrolysis. When they say the anode, the cathode, electrolytic cell, galvanic cell, as well as the what? As well as the electrolyte. And then it says components of the cell, the function of the Saw bridge. Remember, we have 3 functions. Be able to write the half reactions. Use table 4b, or if you are comfortable with using table 4a, then you can use table 4a. Cell notation, polarity, to say which one is positive, which one is negative in terms of the anode as well as the cathode, and the movement of electrons, the decomposition of copper 2 chloride, electroplating, calculation, as well as what? Substitution. So when it comes to calculations, then which formula are we going to use? that would be the formulas that you have on your formula sheet, and then you will have your table 4A as well as table what? 4B. So if you look at your formula sheet, you will see that the cathode represents what? Reduction, which also represents what? Your oxidizing agent. So if you are lost and you are still maybe confused to say which one is the oxidizing agent, you can go back to the you can go back there on your data sheet, and then this is the information that you will get to say if I have the anode is where oxidation is taking place, and therefore the anode will therefore become my what? My reducing agent. Okay, so please make sure that you familiarize yourself with the formula sheet that you have there. Then let's have a look at the following. It says the cell in the diagram below has a copper electrode connected to a silver electrode and is set up under standard conditions. Okay, also remember to study the standard conditions that we have, which is our temperature and our concentration. It says define the term reduction in words. So we have it as the gain of what? The gain of electrons. So just make sure that you define according to the examination guideline. Then we can see that we have copper and what? And silver, and they are in two separate beakers. So what kind of a cell is this? So again, before you even answer, make sure that you understand the type of cell that you have. Is it an electrolytic cell or it's a galvanic cell? So definitely this one is a galvanic cell, because the copper and the silver are in two different beakers or into different solutions. So it says name the component what? The component X. The component X is what? Is the salt bridge. So also know the function of the salt bridge and how the ions move there as well. Okay. So in the structure we have what? The copper and the silver, right? Then it says write down there the energy conversion that takes place in this cell. So because it's a galvanic cell, then you'll have to recall in terms of the energy conversion. So it would be chemical energy to electrical energy. And then if you think of the electrolytic cell, it would be vice versa. So electrolytic cell would be electrical energy to chemical energy. So maybe just an easier way to remember again, because that other one is the electrolytic cell. So electrolytic, so it would be the E and the E, meaning that it would be firstly the electrical energy and then the chemical energy. So if you know the electrolytic cell, you will therefore be also able to remember the galvanic cell. Then it says write down the reduction half reaction of the cell. How are you going to write down the reduction half reaction? You need to go and use your table. So in this case, you will use whatever table that you are comfortable with. But for this activity, I will only be using table what? Table 4B, okay? And for the examination, if you are taught using table 4B or table 4A, please stick to the very same table. Do not confuse yourself, okay? So let's have a look now. So we had what? We had the copper as well as the silver. So if this is the case, we now know that whatever that's at the top, so we can have it as ABC. Whatever that's at the top, it represents our what? Our anode. Whatever that's at the bottom is the cathode, and then here the B is the bridge. So the reduction half reaction of this cell, which one will have which one will undergo reduction? It would definitely be the silver. Okay, so let's have a look now. When we write the oxidation half reaction, what are we going to write? We are going to write it from the right, and then we go to the left. Right to the left, and then when we write the reduction half reaction, we write it from the left to the right. So normally I say that for the reduction half reaction, we copy and paste. So let's copy and paste for what? For silver. We have Ag plus by what? Plus by 1 electron to give us what? To give us Ag. So once you have now decided that this is my reduction half reaction, you now need to write what? A single arrow. If you write a double arrow, then you are saying that I am still confused. I am not sure whether it's oxidation or I'm not sure whether it's reduction. So please make sure that you copy and paste. That's for reduction. Reduction, we associated with the what? With the cathode. You copy and paste and then you write what? A single arrow there. Okay. Next one, it says that we need to write the cell notation. So again, we are working with this copper and we are also working with the silver. What is the first thing that you need to do when you write the cell notation? Firstly, we said A, B, C. So whatever that's at the top, it represents the anode. How do we write the anode? From the right to the left. So we'll start with Cu to give us Cu2 plus by what? Plus by 2 electrons. If you want to write the phases, whatever that does not have a charge is a solid. Whatever that has a charge is aqueous. So we're writing it from the right, and then where we're going to the left, but then the arrow needs to face to the right so that we are able to identify properly which one is our oxidizing agent if we need to, and which one is the reducing agent. So then with the silver, then we said that we are going to copy and paste. So when we copy and paste, it will be Ag plus by what? Plus by 1 electron to give us what? Ag. Okay. So from there, so when you write your cell notation, the first thing is that you write your correct oxidation half reaction. Number 2, your correct reduction half reaction. Number 3, you balance the number of electrons. Let's quickly balance here. So for carbon, I already have 2 electrons. For silver, I can see that I have what? I have 1 electron. So what is it that I need to do if I want to balance the number of electrons? I can multiply with 2. So remember, when we balance, we don't add, we don't subtract, we don't divide, we only multiply. So what number can I multiply with 1 so that I can get a 2? So it's going to be 1 multiplied by 2. So what is it that I'm going to have? It's 2 Ag plus by 2 electrons to give us what? 2 Ag. So I'm multiplying the 2 inside the brackets. From there, what is it that I'm going to do? I can then cancel my electrons because I can see that I have 2 electrons for copper. I also have 2 electrons for the silver. From there, you write everything that you have on the left-hand side of the arrow. What do you have? Cu. So this one was aqueous, this one was solid. So yeah, and then aqueous as well as what? As well as solid. So on the left side, on the left-hand side, I have what? I have Cu solid plus by what? Plus by 2 Ag plus what? Aqueous to give me what? Cu2 plus aqueous plus by what? Plus by 2 Ag. Okay. Now if they now come back and say, identify the what? Identify the oxidizing agent or identify the reducing agent. Oxidizing agent is a substance that will undergo reduction. They are opposites. So oxidizing agent will undergo reduction. Reducing agent, a substance that will undergo oxidation. So oxidizing agent, if it undergoes reduction and oxidizing agent undergoes reduction, it means that you are going to look at the half reaction that you have in terms of reduction. Which one is that? It's the one for silver. Your agents are always going to be on the left-hand side, and your agents are always going to be your reactants. But very important, as long as you have the correct what? You have the correct oxidation half reaction and the correct reduction half reaction. So let's see now. Oxidizing agent, a substance that undergoes what? Reduction. Which one is it going to be? Since it's always going to be on the left-hand side, it's always going to be a reactant. Your oxidizing agent can only be what? Can only be Ag what? Plus. It cannot be Ag, which is on the right-hand side. It can only be Ag plus. Which one is your reducing agent? A reducing agent is a substance that undergoes what? Oxidation. Which one then are we going to look at? We're going to look at the copper. If you look at the copper there, the copper is the one that undergoes oxidation. what do we know about agents? They're always going to be on the left-hand side, and they're always going to be your reactants. So therefore, reducing agent must be what? It can only be the Cu solid, okay? The Cu solid, it cannot be the Cu2 plus. Why? Because we are saying agents can only be on the left-hand side, provided that you write the correct oxidation half reaction and the correct what? Reduction half reaction, okay? So I hope that was clear. And then the next one says calculate the initial EMF of this cell under what? Under standard conditions. What are your standard conditions? It's your temperature as well as your what? As well as your concentration. So remember to write those. And then what is it that you are going to look at? So for this one, you can refer to your formula sheet. It would be E cathode minus what? Minus E anode. And then remember we said it's ABC. So what is it that we have in terms of the cathode? We have this value. In terms of the anode, we have this value. So the cathode is 0,80 minus what? Minus 0,34. And you will then see that it will give you an answer of what? Of 0,46 volts. So also remember to write the what? Also remember to write the unit there. So for this one, as long as you are able to identify which one undergoes oxidation, which one undergoes reduction, then you substitute the number as they are. If you have negative numbers, you substitute the negative numbers as they are in the formula. And for example, on this one, the negative, when you multiply the negative with the negative, it would give you a positive. So please remember on that one. The next one, it says the electrochemical cell below makes use of what? Of carbon electrodes. So very important, please make sure that you read carefully. So carbon electrodes to decompose what? To decompose copper to what? Copper to chloride. So they even gave you the name. They also gave you the formula, which makes life easy for you. Define the term electrolysis. So again, you define according to the examination guideline, the chemical process in which electrical energy is converted to what? To chemical energy. So remember we said this one is going to be what? An electrolytic cell, because we have the two electrodes, they are in one solution or in one electrolyte. What type of cell is represented by the diagram above? So definitely we are saying it's going to be what? It's going to be an electrolytic cell there, okay? On the next one, it says identify the following components from the diagram above. So what is A and what is B? So for this one, very important, you need to make sure that you know the polarity. So for the polarity, we are going to use this again on what? On apes. So games are nice on what? Games are nice on apes. What does this mean? In a galvanic cell, the anode is negative. If you know that the anode is negative in a galvanic cell, it definitely means that the cathode is what? Is positive. And then the anode is positive where? In an electrolytic cell. So you start by writing the polarity to say the smaller line is negative and the longer line is what? Is positive. Number two, remember we said we are going to do what? We said we are going to break down the electrolytes. So when we break down the electrolytes, then this is what we are going to have. So when we break it down, the chlorine, so the chlorine will migrate to the positive one, and the copper will migrate to the negative one. So negative migrates to positive and positive migrates to negative. So what did we say? The anode, so this is the anode. The anode is what? Is positive in an electrolytic cell according to this. So again, also you can use that when you get into the examination. So if the anode is positive, it means that this one, definitely the smaller one must be the cathode. Okay, so from there it says identify the following components. So A, definitely it would be the what? A would be the cathode, and then B would therefore be the anode there. Okay, so you use the cell to identify the polarity, and then from the cell you also use that there. Then it says what would be observed at component B when the reaction starts. Remember we said this one is the negative one and that one is the positive one. And then we said that you need to break down the what? You need to break down the electrolyte. And then when you break down the electrolyte, the negative migrate to the positive and the positive migrate to the negative. So if you are going to look at this one, what would be observed? It means that you are then going to have what? Remember we said we are going to use the word apes. That means what? The anode. So this is the anode is what is positive in an electrolytic cell. So if the anode is positive, it means that you would have to write this reaction according to what? According to the oxidation half reaction. Why oxidation? Because we said that that is where we are going to have the what? That is where we are going to have the anode. So if we write it according to the oxidation half reaction, what is it that we are going to see? We are going to form chlorine. And when we form chlorine, hence that's why we are saying that there will be gas bubbles that would be observed. Write down the oxidation half reaction for the above electrochemical cell. So yes, for you to be able to answer this and to be clear, you would then have to start with the what? With the oxidation half reaction. So we said the oxidation half reaction will come from what? Will come from the chlorine migrated to the anode, and we know that the anode, it is where we have what? Oxidation. Number two, we said that we are going to write the what? The oxidation half reaction by writing it from the what? From the right to the left. So hence that's why this would be the correct answer for 6.5 there. Okay. On the next one, it says define the term what? Reducing agent. So again, we are going to define according to the examination guideline. It says reducing agent, a substance that is what? Substance that is oxidized there. And then write down the formula of the reducing agent in the electrochemical cell above. Okay. So what would be it means that we can then start by writing the what? The correct oxidation half reaction that we previously discussed. So if you write the correct oxidation half reaction, what is the definition of a reducing agent? A substance that is oxidized. So remember we said that a substance that is oxidized, so therefore we said that the agents are always going to be where? On the left-hand side, as they are always your reactants. So that means what? That means that your answer would therefore be what? For a reducing agent, it would be the Cl minus there. Okay. So learners, on that note, I would like to wish you all the very best for your paper 2 examination. And I would also like to leave you with the words of Nelson Mandela, which says that it is in your hands to create a better world for all who live in it. Okay? So on that note, again, all the very best learners. And with that, thank you for watching this lesson. See you next time and goodbye.